Welcome to the Diary of a Medicinal Chemist.
If the lead compound or the drug candidate in this case is too soluble, if the drug candidate is too soluble, that means it will not be absorbed. Because when we look at the structure of the stomach and the membranes that lie the walls of the stomach, the membranes they have we have the outer part of the membranes are hydrophilic, while the inner parts are hydrophobic. So if your drug is hydrophilic, too hydrophilic, that means it will remain within the stomach. But if it is too hydrophobic, that means it will transit through, but it will also be trapped in the linings of the membrane. So you have to maintain a balance between the hydrophobicity and hydrophilicity. Now, when we say hydrophilicity, this is simply we are talking about hydro is water. We are talking about loving. When we say felicity, loving. So the degree of the level to which your compound loves water. In other words, the polarity of the compound. We then have the hydrophobicity. Phobicity. Here we are talking about phobia. So that is water hating. You know, lipids, oils, and so on. They hate water. So that is why the membranes through which your drug is going to transit through are sometimes referred to as the lipid membranes, because the inner parts are hydrophobic. They don't like water. So you have to maintain a kind of optimum balance, and that was what Lipinski did with his co-workers, trying to look at a vast number of drugs, I think over 2,000 drugs, trying to look at the trend in terms of the ones that were able to that were absorbed better. And he did find out that once the log P is tending more than 5, it's a signal that that oral drug will not be well absorbed. So there are so many other properties, there are so many other descriptors that you have to be mindful of while trying to look at the absorption of our compound. Now, so we also have the distribution. The distribution simply means how it's going to be distributed to various parts of the body to the target site. You know, the drug is not going to fly to the target site. It has to go through a number of membranes. We have just talked about the membranes, the membranes within the stomach and all. We also have a number of other membranes within the body. We have the blood-brain barrier. We have so many barriers through which the drug has to transit in order to get to its target. Now, so we have a number of things. Here we talk about the bioavailability of the drug. Remember that I did say that when you get an injection, you get it via the intravenous route. Now, if you use a drug via the intravenous route, you are bypassing all the barriers. So the bioavailability of drugs that are administered through the intravenous route is 100%. But if you have a drug that is going through the mouth, essentially you have, let's say, 100 gram of a particular 100 milligram of a particular drug. After using it, it is possible that the concentration that eventually gets to the target will not be more than 20. A lot of things would have happened to remaining 80. Metabolism has taken its part, esterification, esterase, and so many other things would have happened to the other part. So it is not the exact amount that you use that eventually gets to the target. But the most important thing is that the concentration that gets to the target should be enough to evoke the therapeutic benefit that drug is designed for. So these are a number of things that the distribution throughout the body. We'll talk about the volume of distribution, the plasma clearance, and so many other. There are so many very interesting descriptors, very interesting topics that we need to look at when we are talking about the distribution of the drug. Also, we look at the metabolism. Now, metabolism occurs in various parts of the body, but the major organ for metabolism is the liver. Now, the liver acts like what I would describe as the custom office or the custom department of the body. In other words, it tries to detoxify. Number one, it detoxify any foreign agents that comes into the body, and it does that. It is not selective, it is not biased. It is not selective in the sense that it doesn't say because this is a drug. It doesn't have that ability to recognize a drug and say, okay, because it is a drug, I will allow it to pass. So it treats every exogenous agent that gets into the body fairly the same way.